All right, problem 3-116. This problem is a checkpoint for using function notation and identifying domain and range. It will be referred to as checkpoint 3b. Given g of x equals 2 times the quantity of x plus 3 all squared, state the domain and range, calculate g of negative 5 and g of the quantity a plus 1. Then find the value of x when g of x equals 32 and when g of x equals 0. Check your answers by referring to the checkpoint 3b materials located at the back of your book. If you needed help solving these problems correctly, then you need more practice. Review the checkpoint 3b materials and try the practice problems. Also, consider getting help outside of class time. From this point on, you will be expected to do problems like these quickly and easily. Well, this one's asking for just a little bit, isn't it? So let's get started. First thing here, we're talking about the function g of x equals 2 times the quantity of x plus 3 squared. I'm going to go ahead and write that down here. Let me get some of my stuff out of the way. So we have g of x equals 2 times the quantity of x plus 3 squared. They want the domain and range. They want us to calculate when the input's negative 5, when the input's a plus 1, and then they want us to find what the input would be when they're given the outputs. So let's move down here. I already took the time to graph this on my calculator, and I would advise that you do that. I pulled my screen over here so we could see it. Now this is quadratic, so we do have a parabola that's going to open up, and it's going to go on and on forever, both ways here. So we can already talk about our domain. It's going to be all our possible values or input values of x here, and that should be all real numbers. There are going to be no holes in this graph. It's going to continue left and right forever. It's going up, but it's still going left. Our range is our span of output values. Remember, we're just looking at our y-coordinates. Our lowest point on the graph is right here, and its y-coordinate is what? That would be 0, and then it extends on upward forever here. So pretty much like out to positive infinity there. So we can say our y values are going to be greater than or equal to 0. 0 is our lowest number. All right, so the next part of it here, this problem is asking us to calculate g of negative 5 and g of a plus 1. Let's start out here with g of negative 5. Now if I look at my graph, I go back 1, 2, 3, 4, 5. If I'm at negative 5 here, my output looks like it's going to be somewhere right up around in here. I could probably check my table and it would give me what the exact value would be. Or you can take it and you can just plug it in to come up with your value as well. So I'm going to say, replace my x with my negative 5. So 2 times the quantity of negative 5 plus 3 squared. Negative 5 plus 3 is negative 2. So we have 2 times a negative 2 squared. Negative 2 squared. Negative 2 times negative 2 is 4. And then 4 times 2 is 8. So we get 8 as our output when negative 5 is our input. And if you look on here, it looks like that's about what we got there. So that is our answer for that part. And then remember, it asked us to plug in a plus 1 as an input. Let's go ahead and do that. Let's do that right here. So g of a plus 1, our function g of a plus 1 equals 2. And now I'm going to put in, where I had my x, I'm going to put in an a plus 1. So I'm going to have an a plus 1, and then remember we're still adding the 3. So plus 3, and that whole thing is going to be squared. Use your order of operations to simplify. A plus 1 plus 3, well 1 and 3 add to give us 4. So we're saying 2 times the quantity of a plus 4, still squared. Do not distribute the 2. That would be going out of order for our order of operations. We need to use our exponent first, so we're going to square this binomial. And remember, this is not taking the 2 and distributing it to the a and to the 4. If you need to use your generic rectangle, maybe I'll do that. I haven't done one in a while. Let's go ahead and do one of those. This is a common mistake when some students see that the quantity is square. They just want to put the 2 on each of these. But you have to remember, it's a plus 4 times an a plus 4. So the area of this part of the rectangle, a times a, is a squared. A times 4 is 4a. A times 4 is 4a. And 4 times 4 gives us 16. So we're looking at 2 times a squared. Now we have a 4a and a 4a. When you add those together, we should have 8a. And then plus 16. And lastly, we need to distribute our 2 through, because we have 2 of these, it says. So 2 times a squared is 2a squared. 2 times 8a plus 16a. And 2 times 16 will give us plus 32. So that is our output when a plus 1 is our input. Now the last part of this checkpoint problem asks us to figure out what the inputs are, or what is the value of x when the output is 32 and when the output is 0. Now based on the graph that I've graphed here, I cannot see where my outputs are 32, but if you think about it being a parabola, 32, if we extended our axis up here, okay, it would be way up here somewhere. Our parabola would have 2 points on it. 2 points on it there that have y values or output values of 32. So we should come up with 2 answers for that. And when our output value is 0, it looks like we're going to have 1 answer, and it looks like that answer should be -3. So let's go ahead and solve those here. So we said, what is g of x when our output is 32? And the second problem, just so I don't have to scroll up and look for it in a moment, would be, what is g of x when the output is 0? Well, I'm going to take my g of x, since g of x equals 32, I'm going to replace the g of x in my original equation. I'm going to substitute 32 in its place. So we have 32 equals 2 times the quantity of x plus 3 squared. So I've just substituted in my 32 for the g of x. And we're going to need to solve this now. I'm going to go ahead here and divide each side by 2. So I have 16 is equal to the quantity of x plus 3 squared. I'm working backwards through my order of operations here so I can get back to what x would be to get x alone. So to undo squaring something, it means we're going to have to end up taking the square root of each side. So I'm going to take that. I'm going to take the square root. Remember, those are inverse operations, squaring something and taking the square root. Now, the square root of 16 is 4. And the square root of the quantity of x plus 3 squared, can't forget that's going to be the absolute value of x plus 3. A lot of people forget that. Now, if your teacher just tells you to skip that and put the plus or minus 4, that's fine. Because I know there's two numbers, there's two values that I could plug in to absolute value brackets to get a true statement here. I could plug in a negative 4, or I could plug in a positive 4 into here to get 4 out, which means that x plus 3 has to equal 4, or x plus 3 has to equal negative 4. And let's go ahead and solve each of those there. Subtract my 3 from each side. I'm going to get x equals 1. Or x is going to equal, when I subtract 3, I'm going to get x equals negative 7. So that means if I were to follow my graph here all the way over where x is 1, and then I would go up and I would figure out where my actual graph meets, or where it intersects the value x equals 1, it should be at the value 32. When I put in 1, I get 32 out. When I put in negative 7, I should get 32 out. Last problem, g of x equals 0. We already predicted here that our answer should be negative 3, so let's see if that happens. Just like on the last problem, I substituted 32 in for the g of x. I'm going to do that here too. So we're going to have 0 is going to equal 2 times x plus 3 squared. And we're going to solve it the same way. I'm going to divide each side by 2. 0 divided by 2 is 0. I have x plus 3 left here. Let's take the square root of each side. Ooh, that's a little fancy there. Now the square root of 0 is 0. And we still get the absolute value of x plus 3. When we take the square root of that quantity squared. Well, there is only one number that is 0 units from 0, and that is 0. So we can just go ahead there and write this one as 0 equals x plus 3. Subtract our 3 from each side, and we'll get our answer. X equals negative 3. I know that's kind of hard to read. I wish it was neater. There it is, a little bit better. Remember, this was our answer as well for the other part. That is the end of this checkpoint problem. Remember, you can check your answers, and there's probably some additional practice in the back of your textbook. Okay, so look for the checkpoint 3B materials in the back of your book. You'll also see your teacher or your math lab teacher or whoever it is that's available to help you if you have additional questions. Like I said, I hope this helped you out there. Thanks for watching.